Hello, welcome to the next tutorial where I would like to introduce you to the first type of statistical test, which is independent t-test. This test is used when we want to look at differences between two groups of objects. This way of collecting data when we expose different people or different objects to different experimental manipulations is called between group or independent design. When conducting t-test, our dependent variable has to be measured on a continuous scale, so at the interval or ratio level, and our independent variable should consist of two categorical independent groups. Let's now have a look at the example we will use in this tutorial. We will have a following setup. In a music download store, new releases were randomly assigned to an experimental group and sold at a reduced price of 7.95 euros, or a control group and sold at the standard price of 9.95 euros. Overall, 102 albums were released on that day, and these albums were randomly assigned to the experimental groups, so we have 51 albums per group. And in this exercise we will try to find out what is the effect of price promotions on the sales of music albums, so if albums sold at a reduced price sold significantly more than the ones sold at a standard price. Okay, now when we know what we want to find out, let's go through the process step by step. Okay, we are in our studio now, and first of all we have to activate packages that we will use for conducting the t-test using library command, and these packages will be dplyr, psych, ggplot2 and hmisc. In case you have not downloaded these packages yet, please do so, and if necessary you can find the instructions on how to download packages in the installing and updating packages tutorial. Okay, let's now import our dataset into R. We will use the readTable command and assign the data to the object music sales. So let's run this command. Now we can have a look at the data. Music sales, you can see that we have the product ID, and then we have two variables, which is the unit sales in the second column, and then the group, which is independent variable. And as you can see, the group is denoted by number 1 and 2. Okay, let's go back to our script now, and we will use a factor function now to create a coding variable or a factor, and the labels we will use will be low price and high price, and the labels should correspond to our numeric levels. So in our case, as we saw for the group variable, it's 1 and 2, so level 1 will correspond to label low price and level 2 will be high price. So this is what we will do now. We run the command. Perfect. And before we start conducting the test itself, we will explore our data. The command str or structure will provide a quick overview of our data frame music sales, so let's run it. In the output we can see the number of observations, number of variables, as well as the type of the variables. Let's go back to our script. We will now use the head function to display the top 6 rows. Let's run the command. In the output you can see the top 6 rows of our data set. And we can continue with inspecting frequencies. So to do this we will use a table command, and we will produce a contingency table for the variables unit sales and group, as you can see here. Let's run the command again. We can see an overview of the frequencies in the console. We can, for example, see that 6 unit sales were sold in 18 stores where albums were sold for low price of 7.95, and in 9 stores with a high price. And to inspect these frequencies in the graph, we can create a histogram now using the ggplot command. So let's go back to our script, and we will also use the gmhistogram function to plot the data grouped by our grouping factor price. We will use the faceit_rep function, and don't forget about the tilde in the argument. We will now run the command. Let's wait for the histogram. Perfect, now we can see it in our plots window. Okay, in the next step we can inspect descriptives using the describe command from the psych package. This command will display the summary statistics, so let's run it. And in the output we can see basic statistics such as sample size, mean, standard deviation, median, minimum, maximum range, and so on. In order to get the descriptives by group, we can use the describe by command from the same package, and this will report basic summary statistics by our grouping variable. So let's run the command, and now we can see the same statistics, but they are displayed for each of our groups separately. So first we have the statistics for low price albums, and then we have them for high price albums. Okay, we now have an idea about our data, but let's also explore them with some more graphs. First of all, let's create a box plot to display our music sales data using again the ggplot and geom box plot commands. We will display our group variable on the x-axis and unit cells on the y-axis. So let's run this. We can see again a nice box plot, and it shows us the range of scores, the middle 50% scores represented by the boxes, and the upper quartile and lower quartile of scores represented by whiskers here. The outliers and extreme scores that were detected are shown up as points on the box plot. And the line in the middle of the white box represents the value of the median, here and here, and we can see that the median for low price albums is higher than for high price albums. Okay, let's create one more graph, which will be plot of means. We again start with ggplot command, and in the next layer we use a summary function, stat summary. Since we want to plot means, we will specify that mean should be displayed by using argument fun.y equals to mean, and the argument geom equals to bar will display values as bars. And we also want to add error bars, therefore we will add another layer using command stat summary with an argument fun.data, which equals to mean CL normal, and this will add the standard 95% confidence interval. To add this in the form of point range geom, we will add the geom point range argument. And we also add labels and format the graph. Okay, we can run the command now. And we can see again the plot of means in the plots window. And looking at both of the graphs, it seems like there is a difference between the two groups. Even here you can see that the mean is higher than for lower priced albums than for high priced, but the question is if this difference is significantly different, and this is what we will find out by conducting the t-test. But before we do this, let's have a look on our hypothesis. In our example, we can formulate null hypothesis, for example, in the following way: that there is no difference between the mean sales of albums for the two different prices, and hence the alternative hypothesis could be that there is a significant difference between the mean sales of albums for the two different prices. We should also have a look at the test assumptions before conducting the test. For each test we usually make some assumptions, and if these assumptions are true, then we know that we can take the test statistic and the p-value at their face value and interpret them accordingly. And since independent t-test is a parametric test based on normal distribution, we will have the following assumptions. The first one is that the normally distributed sampling distribution, and in order to determine if this is fulfilled, we use the central limit theorem, which says that if we have a sample which is bigger than 30 observations, we automatically assume normality of sampling distribution. And since we have 51 observations per group here, we can apply the central limit theorem and assume the normality. Then the data has to be measured at least at the interval level, and the measure of the dependent variable in our case is scale, which means that it is measured at least at an interval level, so the assumption is fulfilled. Then we have independence of observations, which means that values in different treatment conditions have to be independent. This condition is fulfilled as we know that products were randomly assigned. And last but not least, we have the homogeneity of variance, which means that the variances in the populations from which our samples are coming have to be roughly equal. But you don't have to worry about this assumption too much, because even if this assumption is violated, there is an adjustment called Welsh test, which corrects for unequal variances, and actually this is the default setting in R, so no worries about this. And one more note: to complete the procedure we have to choose a level of significance, and in this example we will use a standard significance level of 0.05. Okay, now it's time to run the t-test. We now have a function that runs the whole test in one step, and this function is called t.test. You can see it here. And if we have the data for different groups stored in one column, as it is in our example, then we will use the following format. We start with the t.test command, and then we specify the dependent variable, which is unit cells in our case. Then we use the tilde sign, and we specify the predictor or the independent variable, which is group in our case. And in the second argument, data, we will specify the data frame that contains our two variables, which is music cells in our case. So you can see it here. Now we can run the t-test. It's very easy, and you can see the output now down here. First we have the t-value, which is 2.056, and the t-value is the calculated difference between population means represented in units of standard error. So the greater the magnitude of t, the greater the evidence that there is no significant difference, and the closer t is to 0, the more likely there isn't a significant difference. Then we also see the p-value, which is approximately 0.042, and p-value goes arm in arm with t-statistics, and it tells you what the probability that your results could have happened by chance is. And since the p-value is lower than 0.05, we can reject the null hypothesis of no difference between the groups. We also have the degrees of freedom here. Note that they are actually not 100 as you would expect them based on the calculation, which is sum of observations in both groups minus 2. So in our case, sum of observations is 102 minus 2, which is number of groups. So it should be 100, but actually it's 99.15. This difference is because of the Welsh correction, which adjusts the degrees of freedom based on the homogeneity of variance, and R implements this correction by default, so it's okay for you to report the adjusted results. Then we can also see confidence interval, and the confidence interval is a range around the test statistic that is believed to contain, with a certain probability, in our case 95%, the true value of that statistic. In our case, we could say that with 95% probability, the true value of the population mean difference will fall between 0.088 and 4.932. Finally, we are given the means of the two groups, low price and high price albums, but we already know this from the descriptive statistics. You can calculate most of these statistics by yourself in R, and you can find these commands on the website, but the interpretation would be the same, so I will not go through them in this tutorial. One more note before formulating the conclusion: if we wanted to force R to assume equal variances and not to do the Welsh correction, we could use the var.equal command or argument in the t-test command, and in this case we first have to test if the assumption of equal variances is fulfilled by using Levin's test, and then we do the t-test. Okay, we should now interpret our results and findings in terms of our marketing research problem, and since we said that we can reject the null hypothesis because p-value is lower than 0.05, we can conclude that there is a significant difference between the number of albums for 7.95 euros per unit and 9.95 euros per unit. And we could report the results in the following way, as you can see it here. So on average, products sold more units at the lower price point of 7.95. You report the mean and standard error compared to the higher price point of 9.95. Again, you report mean and standard error, and this difference was significant when report the t-statistic, p-value, and degrees of freedom. That's all for the independent t-test. Thank you for watching the tutorial.